My name is Michael J. O'Mahony, and I'm the head of the Process, Energy and Transport Engineering Department here in CIT MTU. It is my pleasure to introduce Michael Ring. Michael will outline our programs in automotive management and technology. I'm here to tell you about our Honours Level H BEng programs in chemical and biopharmaceutical engineering and sustainable energy engineering. Over to you, Michael.
Thank you, Michael J. Hello, my name is Michael Ring, and I'm a lecturer in the Process, Energy and Transport Engineering Department. Today, I'm going to talk to you about the automotive business and transport management qualifications at CIT MTU. But first, a little bit about me and my career path, which I feel is very relevant to you today. Just like those of you watching this video and wondering what job or career would you like, I too scratched my head over that one. For me, a little over 20 years ago, I had completed my Leaving Cert, and I'd asked myself the same question you are asking yourself today. What should I do? I had a real passion and interest in cars and knew I would like to work either full-time in the automotive or transport industry. My father worked as a mechanic, and having worked with my dad on weekends and school holidays, I decided I wanted to further my knowledge of the automotive industry by gaining a relevant third-level qualification. As for what I'd do after graduation, I had no idea, but I knew I wanted to try and turn my passion into my livelihood. Fast forward 3 years later, and in June '99, I graduated from CIT after completing a national diploma in automotive technology and management. After graduation, I worked for 20 years in the automotive industry for Ford Ireland, entering on a graduate programme and progressed my way to the role of National Fleet Sales Manager. Along the way, I went back to CIT at night time and I completed an honours degree in business management and marketing. I loved my time in the automotive industry. However, in September 19, after 20 years working in the industry, I felt I needed to give back and share my knowledge and experience with future leaders of tomorrow. When an opportunity presented itself at CIT, I seized the moment and took up a lecturing position. Let's look at the automotive industry. It's so much bigger than you think. It's important to grasp that we're on the verge of an automotive revolution. We've already seen the start of this with certain vehicle manufacturers only choosing to offer hybrid or fully electric vehicles. The automotive industry as we know it today will change in the coming years at an unprecedented rate, with many experts citing that we will see more change in the coming decade than we've seen in the previous 50 years. Albert Einstein famously once said, "The measure of intelligence is the ability to change," and this change within the automotive industry will come about as we embrace emerging technologies along with the global desire to transfer to sustainable methods of transport. The automotive industry of the future will include electric vehicles, autonomous vehicles, connected vehicles, shared mobility services, and enhanced vehicle software, pretty similar to what we see today on smartphones. We see these as the pivotal platforms of change within the automotive and transport industry in the coming decade. It is increasingly likely the entire automotive industry will change its production landscape within the coming years, and we as consumers will also be required to alter and redefine our mobility requirements as we play our part in the sustainable transport and climate change. All of these impending changes will only be possible by having highly educated and skilled graduates available to drive our automotive and transport industries into the future. So we ask, what have we at CIT MTU done to embrace this change? Firstly, I need to mention that our graduates are in high demand and we currently cannot meet all the expectations of industry. We have graduates employed in dealerships, vehicle manufacturers, fleet management providers, and telematics providers. We've partnered with industry and software providers like CDK Global to develop and design qualifications that are relevant and provide graduates with key skills needed for industry. In CIT MTU, we offer 3 degrees aimed specifically at students who would like to pursue a career within the automotive and transport industry. Firstly, we're very proud to offer Ireland's very first Level 8 Bachelor of Science honours degree in Automotive Business Management and Technology. CR110 is the course code. This 4-year honours degree has been developed in conjunction with the automotive industry to meet the specific requirements of industry and therefore provide graduates with significant advantages when seeking employment in the sector. Particular emphasis is placed on the course content with a mixture of management, financial, legal, strategic analysis, and practical modules that provide graduates with rapid opportunities for career development. The programme is delivered through a combination of theory and practical-orientated modules. Work placement is also incorporated in Year 3 and provides the opportunity for students to apply their learnings to date while gaining valuable industry experience. Work placement also provides students with a great opportunity to discover potential employment opportunities prior to graduation. In addition, there is a CDK Global Bursary worth €3,000 available for a first-year student. Graduates of the Level 8 automotive course would be in a position to see career opportunities at the higher end of the automotive industry, ranging from motor dealerships, vehicle manufacturers, large fleet and rental operators, automotive leasing companies, to name but a few. For students wishing to pursue a career in the area of vehicle technology and transport, we also offer a Level 7 Bachelor of Science in Automotive Technology and Management. CR046 is the course code. This 3-year degree will lead to rewarding career opportunities in many types of the automotive industry. Employment opportunities include supervisory and technical positions within sales and after-sales sectors of the industry, along with elements of the fleet industry. The course is taught through a combination of lectures and practical modules such as motor vehicle technology, workshop control, and automotive electronics. Students who successfully achieve a Merit 2 or higher may progress to the 1-year add-on Level 8 Honours degree in Bachelor of Science in Transport Management. CR-TTMGT8 is the course code. Transport plays a significant role in the economic activity both within Ireland and worldwide. The transport sector has recently been thrust into the limelight as a critical service that has helped Ireland cope with the COVID-19 pandemic. The course provides students with knowledge of transport planning and logistics operations, international trade, and transport telematics, to name but a few, through a combination of lectures, practical classes, and individual work projects. Work placement is also included as part of the programme. Today, we've discussed one of the most exciting industry sectors, with the potential to revolutionise and change the world as we know it. The technological advances could be likened to the big tech revolution seen within companies like Apple, Google, Amazon, and Microsoft. The question you need to ask yourself is, are you passionate about the automotive and transport sector? Do you want to be part of the next wave? I would like to finish by saying, I've been where you are now. It is a daunting task to choose a career path, but let me say this. It does not matter if you are not interested in the automotive or transport sector. What is important is that you choose a career path that you will be passionate about and enjoy. I would like to thank you for your time and wish you the very best in your academic endeavours. Michael J., back to you.
Thank you, Michael. I suppose the very first question is, why would you want to become an engineer? Engineers apply science and maths to the solution of very real-world problems. If you enjoy solving problems, like maths and science, I would like to contribute to the solution of problems like reducing carbon emissions through replacing carbon energy sources with renewable sources, or helping to scale up the production of a COVID-19 vaccine, just to mention two very topical problems that need an engineering response in the immediate future, then you should seriously consider engineering as a career. It can be useful to clarify the difference between scientists and engineers. Scientists usually perform pure science, exploring how nature works. Scientists answer the question, why? Engineers usually perform applied science, putting scientific concepts and maths to work to develop economical solutions to technical problems. Engineers answer the how question. The basic purpose of engineering is to devise and provide devices, machines, systems and processes to promote, improve, sustain or protect the living standard of the human race. For example, scientists have been busy in developing a vaccine against COVID-19. Let us assume that this is successful. The volume of the vaccine that would be required to vaccinate billions of people around the world is a huge manufacturing challenge. Design, installation, commissioning, operating, and maintaining the vaccine production facility is where the engineer comes in. Henry Petrusky put it well when he wrote, "A scientist studies what is, an engineer creates what never was." Would you like a career that is exciting, challenging, and rewarding, is different from day to day, month to month, is very well paid, has a high earning potential throughout your career, gives you a high level of responsibility, allows you to travel, then you should consider engineering as a career choice. This leads me on to what is chemical engineering. Chemical engineers transform raw materials by physical, chemical, and biological means into useful products. Chemical engineers are pioneers in the application of biochemistry to the manufacture of new biotech-based drugs and products such as vaccines. They have an incredible impact to the manufacture of the life-saving drugs, materials, and devices used for human healthcare. In the area of food and beverage, chemical engineering know-how can be credited with improving the conversion of raw foodstuffs into safe consumer products of the highest possible quality. The environment is chemical engineers work to minimize our impact on the environment by developing and applying technologies such as catalytic converters and by developing more efficient processing and recycling methods. Our modern society relies on the work of chemical engineers. The large number of industries that depend on the synthesis and processing of chemicals and materials place the chemical engineer, with their unique training, in great demand. The chemical engineer is unique because he or she can move across a variety of roles and responsibilities within an organization, can move across industrial sectors, scale up processes developed by chemists and biologists. So, what makes a good chemical engineer? Chemical engineers need to be problem solvers who enjoy science and maths. They must be looking for a challenge and be excited by a degree choice that will help them develop a wide range of skills, including specialist scientific knowledge, project management, resource management, health and safety, teamwork, communication skills, leadership skills, information technology, business and legal knowledge. CR 105 is our BEng Honours in Chemical and Biopharmaceutical Engineering, accredited to Master MEng level by the Institution of Chemical Engineers. This programme recently retained its IChemE accreditation to an M standard. Qualifications accredited at M standard meet the full academic requirements for Chartered Member and Chartered Engineer, CEng. M standard recognises integrated degrees that provide both a solid academic foundation in chemical engineering, plus the advanced chemical engineering knowledge and skills. This means that you can become a chartered or professional engineer without any further academic formation if you graduate from CR 105 BEng Honours Chemical and Biopharmaceutical Engineering. This programme is also accredited nationally by Engineers Ireland. So, what does the future hold for our latest graduates? Very high levels of graduate employment to date, highly paid, 30 to 42,000 graduate starting salary. Some final year students will have a job offer before they finish their degree. Accredited degree which allows you to work abroad. Graduates working in many sectors, but the majority in the biopharma and pharma industries. Minimum entry requirements are the leaving certificate in 6 subjects and a maths grade of at least H4. In 2020, the CAO points required were 443 points. Of this year's first year students, 4 are above 600 points with a highest of 625 points and 7 are in the range 500 to 599. The median is 500 points. You can also enter through common entry engineering where the entry points were 411 points. Common entry allows you to join chemical engineering after first year. There may be some additional electives that you are required to take in order to progress to chemical engineering from the common entry route. So, what makes chemical and biopharmaceutical engineering in CIT different? Well, a broad focus to allow employment in many industrial sectors. A biopharmaceutical content to prepare graduates for changes in the pharma industry. Teamwork and individual learning. Excellent staff-student interaction. We've got 7 chemical engineers and 2 industrial chemists. A mix of industrial academic experience. Integrated consideration of safety, environmental and economic impacts. Project-based learning along with computer-aided learning. And we've got a semester-long work placement which runs from June to the following January. Now I'd like to talk to you about the Bachelor of Engineering Honours, Level 8 in Sustainable Energy Engineering, CAO course code CR 510. It is an inescapable truth that energy is one of the fundamental needs of modern societies. Future energy sources that are not sustainable are not a long-term solution. Sustainable energy engineering involves the understanding and application of the engineering and technological principles of energy conversion and use. Sustainability requires that the proposed energy solutions are truly viable into the future and that the impact on resources, the environment and society as a whole are minimised. The need to decarbonise our energy supply is fundamental to achieving this goal. I spoke earlier about engineers as problem solvers. Just think about how many problems have to be solved to change our electricity generation capacity from carbon, non-renewable, to a predominantly non-carbon, renewable and sustainable system. This is a long-term project that is well underway. It involves the design and development of wind, solar, biogas and wave-powered alternatives. Graduates of our Sustainable Energy Engineering programme are contributing to the financial feasibility and site selection, design and planning, commissioning, operating and maintenance of these replacement generating capacities. This course has been running for 12 years. It has 320 graduates with excellent employment opportunities. It is one of the first honours energy engineering degrees in Ireland. It was the first professionally accredited honours energy degree in Ireland. It has the highest graduate numbers in Ireland with over 320 graduates. It has excellent graduate results and employment, and we have over 100 industry partners. It was re-accredited by the Energy Institute in 2016. This programme is accredited at undergraduate level by the Energy Institute, which enables graduates to progress towards chartered engineer status. So what do you study? Well, in the mechanical engineering stream, you study heat and fluids, mechanics, design and materials. In electrical and electronic engineering, you study topics such as motors, generators, controls, sensors and data transfer. In the chemical engineering stream, you study chemistry, process engineering and systems engineering. Within computing and ICT, you study microprocessors, programming and modelling. Then there's course-specific thematic content around energy and sustainability. Modules include sustainable energy systems, solar energy, wind energy, sustainability and transport, energy management, building energy rating, hydro and ocean energy, biomass, and then modules in management such as product design, operations and project management, projects and work placement. There is a work placement for a minimum period of 10 weeks in year 3. So what are the career opportunities? Graduates over the past 5 years have been employed as process engineers, design engineers, and energy analysts. All major industry now requires that its energy use be minimized. And so energy graduates are working in all sectors of industry, including biopharmaceutical, biomedical devices, energy supply utilities, and manufacturers of energy systems. Potential areas of employment include energy management, energy systems design, energy project management, research and development, energy engineers, process engineers, design engineers, and engineering consultants. If you would like to continue and complete a master's or PhD, there are lots of research opportunities. Within CIT MTU, we have Zero 2020, which is the National Building Energy Retrofit Testbed, which has ultra-low energy use. We have what was, up until recently, the largest PV array battery in Ireland. We have a wind turbine, and we also host the National Sustainable Building Energy Testbed. MESO, our research centre, undertakes research in a number of different applications within the general domain of mechanical, agri and energy system simulation. Current themes include control and optimisation of smart grid connected buildings, ventilative cooling, demand response analysis. So, if you do choose the Bachelor of Engineering Honours Level 8 in Sustainable Energy Engineering, CAO course code CR510, you will find the following are useful Leaving Cert subjects: engineering, physics, chemistry, construction technology, and DCG. The CAO points in 2020 were 320 points. The minimum entry requirement for maths is grade 03 or H6. To conclude, I would like to reiterate the wise advice given earlier by Michael Ring. What is important is that you choose a career path that you will be passionate about and enjoy. Thank you for your attention, and I wish you the best for the remainder of this academic year, and I hope to welcome you to MTU next September.